Hello, everybody, and welcome to today's presentation. Unleash the power of your microservices through APIs, brought to you by WSO2. I would like to introduce you to our presenter, Nuwan Diaz. Nuwan works as a director at WSO2, an open source integration provider. He is a member of the architecture team at WSO2, which spearheads the strategy and design of WSO2 products. He spends most of his time working closely with the engineering team, which is responsible for the research and development of the WSO2 API Manager. Nuwan is a member of the Open Source API Security Group and has spoken at numerous conferences around the world on the topics of APIs, integration, security, and microservices.
My name is Nuwan Diaz, and I'll be the host for your webinar today. I'll be the main presenter. So during today's webinar, I hope to cover the things on the topics of how APIs can power up your microservices and how they are quite essential to a microservice architecture. So as Billy mentioned, I work as the director of API architecture at WSO2. So I'll briefly mention about what we do at WSO2. So our primary objective here at WSO2 is to help digital-driven organizations be integration agile. So what that really tries to say is that so as organizations are moving towards more and more microservices and modern ways of developing applications, most organizations are focused on developing their services layer, their microservices, and the reason for doing that is to become more agile to meet the demands of the business. And as we go along in this process of developing lots of microservices, something that happens behind the scenes and something that we probably might miss to see is that the integration component of this is becoming more and more important. Because as we end up with tons of microservices to deal with, tying them up, snitching them up together is actually the process of integration. And while we are gaining on the fronts of agility in terms of developing and managing our microservices, what generally tends to happen is that as the integration layer becomes heavy, that particular component becomes a waterfall, and the traditional ways of doing integration in the history hasn't really turned its head on yet into the areas of agility. So that's what we specialize on, basically make the integration layer agile, because as we've seen, there's almost nobody focused on these on making the integration agile. And if you do not focus on this area, what typically happens is that although you gain agility on the fronts of developing your services, you end up being waterfall on the integration fronts, which kind of loses your objective of becoming agile. So we at WSO2 specialize on this particular area. So to give you a brief introduction, we are the #1 open source integration vendor, and the sixth Apache, the committer base, the largest Apache committer base, the sixth largest. And we are also the 7th largest open source vendor in the market. So we go along doing this with 4 main products. So we have products operating in solving problems in the domains of enterprise integration, and also solving problems in the domain of identity and access management, and also on the API management space, which is the area that I am primarily focused on here at WSO2. And also we have a component or a product solving problems in the streaming analytics domain. So all our products are free and open source, comes with an Apache 2 license, so you can use them. And our main source of revenue comes through subscription and support. So that's how users engage with us on a commercial sense, and that's our main source of revenue. So that basically is a brief introduction of where I come from, what I mainly do here at WSO2, and a little bit about the background of the nature of the work I do here at WSO2. So to get on into the details of today's topic, as I mentioned before, I will be discussing on why APIs and microservices play a critical role in a microservice architecture. So to begin our discussion, I'd like to set the stage by discussing why we need microservices in the first place, because understanding that is important. Um, so to understand that, I'd like to start off by explaining what is a monolithic application and why are we moving away from it. So if you look at a typical monolithic application of a retail store, for example, you will have this monolithic application conducting various types of functions in the areas of like browsing your product catalog, functions that perform orders, functions that modify your inventory, and functions that perform shipping. So a monolithic application would be a single application that has all of these functions embedded in it. So um, and if you wanted to scale this application, if you wanted to scale it to have to serve more load, for example, what you would typically do is that you will create more instances of this chunk of an application and load balance your requests across these different instances, these different chunks. So that's what you would typically do. So what is uh, there are lots of applications like this out there in production, and they do make revenue, good revenue for most companies. But why we are kind of moving away from these architectures is because of the demand in the business to innovate and to compete against our competitors. So the business side of an organization is demanding faster releases, fast deployments, fast products that can be put into the market, tried out and tested faster. So what happens with these monolithic applications is that this brings us lots of challenges in the areas of delivering faster. What that means in technical terms is that, so assume that you wanted to fix a bug or introduce a new feature into the inventory function. So on the technical fronts, what you would have to do is that you need to fix that particular bug or implement the feature in the inventory function, and you have to recompile and redeploy the entire application. So although you're just changing the inventory function, the nature of the application causes you to recompile and redeploy the entire application itself. And when doing so, in theory, although you are not changing any of the other functions, but due to the fact that you are recompiling and redeploying the entire application, you have to go in and verify that the other functions remain intact without any unintended impacts. Uh, and therefore, this process is not agile. It takes us a lot of time to verify the entire scope of the application just because we change a small piece of it. So this doesn't really help us to get out to the market faster, and that is and therefore doesn't meet the demands of the business. So that is why we've basically gone into a different mode. So the reality is that we've hit the limits and we can't make the horse go faster. So we've come up with various types of ways to improve this these delays, such as through tools like automation testing, tools like deployment automation, likewise. But we've kind of hit a ceiling on that. So there's a limit on which we can improve this further. So therefore, we really hit the limit of how fast we can make this horse go, and therefore we are now looking at mechanisms to decompose this into smaller units of operations, and that's why, and that's basically the whole world of microservices and why they are important. So when decomposing this, we have to think about the characteristics of microservices and how they would help to solve this problem. So I would like to talk a little bit about the characteristics of microservices. One as a refresher to go through all of these characteristics, and two as a reminder to us that even though we talk about APIs here, um, unless we meet the same characteristics on our API layers, we still lose on our end objective of meeting agility. So therefore, it's important for us to stay razor focused on these characteristics and make sure they are basically adhered to everywhere across the entire plane. So as Martin Fowler explains, some of the key characteristics in microservices are, one of them is componentization. So he explains that one of the most important things in a microservice architecture is to design your components in such a way that they can be independently developed, independently tested, and independently deployed. This is so that you don't have to do loads of testing and verification when you just change single components. So see, as long as they are isolated, the changes that you make to a single component do not impact the rest of the components, and therefore you can independently develop, test, and deploy them without impacting the rest of the system. And when breaking these components down, it's important to think of these components in the form of business capability and not in the form of technical capability. What that means is that when you're thinking about a component, or rather several components, just because these components are on the same technical capability or technical platform, you shouldn't be considering them as they belong into the same component or same microservice. For example, you could have your orders microservice and your shipping microservice developed on a Java technology stack, and maybe you have your customers microservice developed on a Go or a Python stack. So just because your orders and your shipping are on a Java stack doesn't necessarily mean they belong in the same component or same microservice. The orders and the shipping perform two completely different functions from a business angle, and therefore they should be considered as two independent components. The single responsibility principle is again another critically important factor to take into consideration, and that is basically saying that a microservice should do one function and one function only. So this is again to make sure that that the changes you do to a single component or single unit barely impacts any of the other parts of the system. So smart endpoints and dump pipes are a familiar term by now. So we are almost all of us are familiar with it by now. So in the world of SOA, service-oriented architecture, we had a system where our services used to do the core business logic, and we had something called an ESB layer that did an orchestration across these services. So the ESB kind of like became the central brain that where all the logic was built into on the integration fronts, and that started becoming a center of excellence. And this is basically what caused the bottleneck in the service-oriented architecture world, where we did have our services, but as the ESB became complicated, that became a bottleneck of managing all of our services. So the microservices world advocates a concept of where you shouldn't have a center of excellence, but that excellence should be distributed across all of your services and endpoints. So that's the whole idea behind smart endpoints and dump pipes. And CI/CD also plays a critically important role here in the world of microservices. That is because when you break down a monolithic application into microservices, you will see and you will notice that you will end up with hundreds of or thousands of microservices to deal with. So unless you have a clearly defined and clearly executable CI/CD pipeline, managing all of these thousands of microservices manually is going to be a very tough job. So therefore, unless you have considered CI/CD seriously enough, you really shouldn't be committing yourselves into a real microservice development or deployment. So that becomes a critical factor to take into consideration. So taking all of those into consideration, if you break down our monolith of the retail store into a microservice architecture, this is probably the kind of architecture you will end up with. So you will have independent microservices, each one for performing operations on your customers, customer accounts, another microservice for browsing your product catalog, another microservice for performing or making and updating orders, another microservice for updating your inventory, and another microservice for performing shipping functions. So this is a, a very simple example that I've picked, and as you can see, even in this simple example, we end up with like 5 microservices and lots of interactions between these microservices. So the reasons for interactions, I'll try to explain one or two is, let's take the products microservice for example. So if you are writing a client application that browses your product catalog, the products microservice will be the primary component or microservice that will be serving those requests. But the products microservice needs assistance from the inventory microservice to tell the customer or the client application whether you have enough stock or how much stock you have left in your inventory for that particular item to be purchased. And similarly, when you're purchasing an item, when you're making an order, the orders microservice now needs to place that order, but it also needs to contact the inventory microservice to go and update your inventory when an order is made. So therefore, as you can see, there are lots of interactions between these microservices. So imagine an organization with a fairly complicated and a large application. So they'll probably end up with thousands of microservices, and when you consider the interactions between all of these, it's going to be a chaos of managing it unless you have the proper pieces in picture. So we are going to take a look at some of these potential problems into detail, and then we are going to dive into how APIs can solve some of these problems and what are the best practices of using APIs and API gateways in order to solve these problems. So one of the first problems that we will end up with is on the front of exposure. So out of these microservices, you may have noticed that some microservices need to be exposed externally, and some microservices need to be exposed internally only. For example, your products and your orders microservice needs to be exposed externally, which is what makes it possible for applications to browse your product catalog and make orders. But your inventory and shipping microservices do not need to be exposed externally, because external applications do not update your inventory directly. Right? They are done by either the mostly through the orders microservice, and same for the shipping. So the shipping is always performed as a function of placing an order, and therefore the shipping microservice is internal. And the customer's microservice might be exposed both ways, because your client application might need some information from your user profile for display purposes, and the shipping microservice may need some information from the customer's microservice to ship the order to the customer's home address. So therefore, there can be hybrid services like this as well. So with this kind of architecture, what happens if you expose these microservices bare bone or in their naked form is that it becomes hard for you to manage these exposure layers, but because by default they are just all exposed as is, and there's no control of internal, or there's no separation versus internal, external, etc. Another potential problem is the uniformity problem. So as I mentioned in the beginning, the whole point of us doing this is to make us more agile and more fast. And in doing so, we will probably have different teams developing different microservices. So team 1 could be using one technology stack and their own practices, patterns, and standards for developing their microservice. Team 2 could be using their own patterns and technology stack and practices in developing their microservices. But when exposing these services to consumers, if there is no uniformity across these services, it's going to be pretty hard for the consumers to understand the dynamics of all of these services being exposed. Although in this particular example, we are just showing 3 microservices, the reality is that there will be lots of microservices to deal with when you're building an application for real. So if there's no uniformity, consumption is going to be really hard, and therefore you are not being able to realize the real benefits of going into a microservice deployment. So that's again one of the key problems to address. Another problem that can also result from the previous problem is that based on the needs of these microservices and their security parameters, the security requirements of these microservices could be very different. For example, in a microservice that is being exposed externally might require OAuth 2 based authentication to identify the end user, to check if the end user who is accessing this has the necessary privileges to access this information. Likewise, so the microservices that are being exposed externally require end user authentication, primarily in the form of OAuth 2 in most cases. But microservices that are just internal only may not have such stringent requirements to perform end-user authentication, because the internal microservices just needs to ensure that they are being accessed by only a trusted party within the same trust domain, for example. And therefore, they might have less complex or easier security requirements. But as consumers of these services, there can be different security protocols for different microservices. And therefore, if there's no single point or uniform way of enforcing security on your microservices, again, the consumption is going to be pretty hard. And even when inter microservices are communicating, unless there's a standard way, if the security is all jumbled up, it's going to be pretty hard developing an application for this. So similarly, there are such problems that we can talk about, a lot more problems that we can keep on talking about, such as like enforcing rate limits. If you just expose your microservices in their naked form, exposing rate limits on your microservices is going to become a challenge. And also getting business insights. So most microservices platforms are very good at giving you information about operational analytics, such as your resource consumption, the number of requests you're serving in a given day, things like that. But when it comes to business insights, you really need a centralized or a uniform way of identifying what is really going on in your system. You need a way of understanding how the things that are happening within this domain, within this infrastructure, is really helping your business, or whether it's not helping your business. What kind of relationship does it have to the dynamics of your business? So understanding these become a challenge with a bare or a naked microservice deployment. So similarly, there are lots of problems like this, but I guess you get the idea of the type of problems that we have to deal with when we are dealing with lots of microservices and lots of interactions between them. So this is where APIs come into play and APIs come into the rescue. And there are several ways where APIs can solve some of these problems that we discussed. So first and foremost, in order to solve the problem of exposure, so API gateways help you to solve this problem of exposure, and to immediately solve the problem of the chaotic nature of the interactions between these microservices. So the simple way to do that is to expose all of your microservices through an API gateway layer. And in our particular case, since we had two types of exposure layers, which is the external microservice layer versus the internal microservice layer, in here we'll have to adopt a pattern where we have two gateway layers, one for external consumption and another for internal consumption. And all microservices will only be exposed through this API gateway layer. So the gateway layer becomes the single point of contact for your client application, and therefore doesn't have to deal with the dynamics of figuring out your independent microservices where they reside. The gateway becomes a single point of discovery for discovering your microservices. And another potential benefit that you get from this is that when you expose your services through the API gateway layer, you can also ensure uniformity. So you may have different technology and different patterns in your microservices, which is totally fine. But when you expose them through your API gateway layer, this is a point where we can enforce, or rather enforce governance policies to have organization-wide patterns and standards for external consumption. So this gives you the benefit of the agility of your microservices, where your teams can freely go about developing those microservices. But then at a consumption layer, you control the consumption layer by governance policies that decides the standards and stuff like that. It also solves the problem of security, because since the API gateway layer is now the entry point into your microservices layer, or the gateway layer can take care of all the security related matters. So it will deal with the complexities of the security exchanges that needs to happen. For example, if an end user is if a client application is accessing your products microservice, the external gateway will do the end user authentication for you through OAuth. And if the products microservice now needs to talk to the inventory microservice based on mutual TLS, and then the internal API gateway will take care of the mutual TLS negotiations between itself and the inventory microservice. So your products microservice don't really need to worry about the handling the mutual TLS or switching over from OAuth to mutual TLS and things like that. So the gateway architecture immediately solves some of these problems that we have been talking about. It also helps us in the context of moving away from our monolith into microservices. So for example, if you are in a phase where you are breaking down your monolith into microservices, so chances are that you will be doing this phase by phase. It's unlikely you will do a big bang migration from the monolith to the microservice, so you will do it piece by piece. And when doing this, what happens is that if you just do it in its naked form, the interfaces that your consumers are used to consuming are going to change from time to time as you go along breaking this down. So that's not good for your consumers, because they now feel that the interfaces are changing rapidly and they have to deal with the newer and newer challenges. But if you expose all of your functions or services through an API gateway layer first up, before doing this exercise, then your consumers just have to deal with the API gateway layer. So the interface becomes fixed, and once you proxied everything through the gateway layer, then you can slowly start moving things behind the screen and moving them into microservices. So this again gives us the benefit of not impacting our consumers as we break down our monolith into smaller microservices. So so similarly, having an API gateway layer and designing our microservices according to principles would get us to a certain stage in our journey. But after we've set this all up and we've developed our microservices and we now have a nice API gateway architecture and all, this doesn't mean that our business will stop giving us new requirements and coming up with newer and newer challenges for us. And how do we go about addressing these? And this is where some kind of orchestration needs to come into play. So for example, imagine that you are asked to come up with a function where you can see the unshipped orders that have happened during the past week. So so you have a function or a microservice that gives you details of orders, and you also have a microservice that gives you details of shipments. So now you're asked to come up with a function or a feature where you can see orders that haven't been shipped within the last week or so. So you have two options here. One is you completely develop a new microservice that does this capability end to end, But the downside of doing that is that you will end up duplicating some functionality in your orders microservice as well as some functionality of your shipping microservice, and introduce some new functionality yourself. So that's not really good because you're duplicating stuff. Another approach would be approach that we used to follow in the SOA or service oriented architecture world is that using an ESB pattern. So we use the ESB as a layer of doing integration across microservices, and we build this logic into the ESB, this additional logic into the ESB, and we did an orchestration between the orders and the shipping microservice. So, but we've seen the problems of this approach, where if you follow this approach, the ESB now becomes the center of excellence and therefore becomes a bottleneck. So a better approach of handling this problem is to deal with this layer called integration microservices. So what you can potentially have is an integration microservice that consumes both your orders and shipping microservices, and then adds a bit of integration logic in between and deploys that unit only as an integration microservice layer, and then expose that integration microservice through the API gateway architecture. So this way you don't build a center of excellence, but you have yet another microservice or yet another unit of integration. So you're going away from the center of excellence mode, but still achieving the orchestration that you need and also the benefits of the API gateway. And another requirement that might come along the same lines is how you utilize these microservices for different types of clients. So this is again a similar requirement, such as the requirement we had to go for an integration microservice layer. So this is a case where if you have this, when the same microservice is being consumed by different types of clients. So you may have a products microservice being consumed by a web application as well as a mobile application. So as you know, a web application is capable of displaying a lot of information, but a mobile application cannot physically display a lot of information, and therefore all of the information that is given by the products microservice to serve the web application is not required by the mobile application. So that information can be provided to the mobile application, but it's a waste of resources. It cannot utilize all of that information due to its physical restrictions. So to cater these types of requirements, we again need to come up with some form of something like the integration microservices, where we have independent microservices optimized for serving the relevant types of clients, and then we expose those microservices again on our external or rather the API gateway layer. So as you can see, we've been going along introducing new types of microservices and then exposing all of these through our API gateway layer. So this becomes a problem for us. So, and what is that problem? The problem is that by doing so, now our API gateway layer is becoming fatter and fatter. So although we are becoming more and more agile on our microservices fronts, as we keep on adding those to the API gateway layer, the API gateway is now becoming kind of like a center of excellence. So this is where the microgateways come in. So microgateways is a mode of breaking up this monolith API gateway layer into smaller API gateways called microgateways. So let me introduce some characteristics of microgateways and why they are important. So typically, microgateways have to be designed to scale. What that basically means is that when it comes to scaling, we have to keep certain things in mind, that a component can only be scaled easily if it is independent of other components. Therefore, it needs to have things like self-validating tokens, localized rate limiting. So self-validating tokens basically means that it can validate tokens by itself without the assistance of any other component, and therefore it makes it easy for that particular component to scale. And localized rate limiting, again, same concept. You can do rate limiting by yourself. Offline analytics. So this again is another important factor where you should be able to perform analytics without the assistance of another component. And immutability is also again important for robustness guarantees, and again to help us to scale the exact same unit without having duplicates. So as you all know, microservices operate in contain environments mostly now, and contain orchestration systems. Therefore, micro gateways that we are developing, just as the microservices that we are developing, need to be container native, need to be friendly to operate on container orchestration systems. And it may seem like we need to have like a micro gateway per microservice, but it also needs to support both private jet like independent micro gateways as well as micro gateways that are capable of handling more than one service. CI/CD readiness, again the same thing that we discussed on the fronts of microservices, and also service discovery capabilities, because in the world of microservices, and if you're familiar with container orchestration systems, microservices get deployed and redeployed quite frequently, and therefore their access IPs and all stuff change, and we need therefore dynamic service discovery capabilities in order to route our requests to the correct endpoints. So these are some of the characteristics that are important in micro gateways. So typically, a micro gateway operates in the form of a developer experience. What that basically means is that usually what you will have is an API definition source being provided to a micro gateway compiler, and this micro gateway compiler should give you the micro gateway runtime. So this is like a reference architecture for a micro gateway in order to meet the demands that we are looking for. And what's important in this architecture is that instead of having a regular monolith gateway, we now have a much more decentralized gateway architecture, which gives us much more flexibility in scaling. So what that means basically is that, so assume you have lots of requests coming to your products microservice because more people are browsing your products, but you have only fewer people making the orders. So you probably need more instances of your products microservice, but less instances of your orders microservice. And just because you have more instances of your products microservice, if you have a regular or a monolith gateway architecture, in order to cater that requirement, you have to scale the entire gateway architecture. But if you have micro gateways, you can just scale the micro gateway component only without scaling the other parts of the system which do not require to be scaled. And when it comes to security, typically micro gateways offer standard OAuth 2 based security. So what happens in this flow is that as in the typical OAuth flow, a client application would acquire a security token, and that token will be sent to the micro gateway to access resources on a micro gateway. The micro gateway will communicate back to the security token service for validation, and then if the validation is successful, pass on target service. So the one problem with this architecture is that, as you can see, as you can see in number 4, there's a link between the micro gateway and the STS. So one of the problems that can happen is that if you scale the micro gateway rapidly, this potentially would need your STS to be scaled up too, because as your micro gateway scales up, the number of requests that go to your STS would also increase, and therefore the micro gateway cannot scale on its own. It's not an independent unit in this particular case. So more beneficial or recommended architecture would be to use self-validating tokens, like I mentioned before, or are the self-contained tokens, which could be signed JWTs. So in this particular case, what happens is the client again requests a token from the STS, and the STS actually gives a token, but this token is special in the sense that this is a self-contained access token, typically a JWT, which can then be sent to the microgateway, and the microgateway, by verifying the signature, verifying the authenticity of this JWT, can trust this token without having to communicate to the STS. So this way, there is no link between the microgateway and the STS, and therefore, the microgateway becomes an independent component, which makes it much easier for us to scale it. And also localized rate limiting. So with this microgateway architecture, what we also have is a localized rate limiting model, where products, where if you want to enforce a particular limit on a products microservice, that is enforced by one microgateway, and the other limits are enforced by the other microgateway. There's no shared infrastructure between the two, as in the mode of a regular gateway. So again, this can act as a reference architecture for any microgateway that you are trying to deploy. So when it comes to analytics, so usually we have separate analytics components or engines performing analytics for us, and usually there's a link between. Usually, how things work is that the gateway pumps information to the analytics engine, where the analytics engine would process it and then produce the results in whatever the form that makes sense. Again, so this direct link between the microgateway and the analytics engine does not really help us to scale and run the microgateway in isolation. So a better, or probably a good reference architecture would be where the microgateway keeps a track of all of the things it does in the form of log files or similar in its own file system or in a shared file system, and keeps rotating these files time by time in order to reduce the disk growth. And then an offline process uploads these files to the analytics engine for further processing. So this way, we break the direct link between the microgateway and the analytics engine. So these reference architectures are, of course, coming from like the background of some of the work that we have been doing here at WSO2. So these are mostly based on that, but these can be used as general ideas, concepts to realize the real benefits of doing microservice architectures. And also, like I mentioned before, microservices are now mostly being deployed on containers and container orchestration systems. So again, what's important when it comes to CI/CD facts mostly is the importance of being able to easily deploy or create these artifacts that can be deployed on container orchestration systems such as Kubernetes, and also contain images such as Docker, for example. So again, this can be used as a reference architecture for building your microgateways and their respective CI/CD pipelines. So the concept here is that, again, you get the API definition source from somewhere. It could be a Swagger file, it could be a file hosted on GitHub, it could be an API management system. Wherever the source might be, you get that definition from the respective source and give it to a microgateway compiler, which can then generate the respective runtime for you, whether it's a VM, whether it's a Docker image, or whether it's like any other container orchestration artifact type that you want. So as you can see, the microgateway is like a developer first experience, where you have a build. You may have seen the microgateway compiler being discussed before. So it's a build and a deploy model. So one of the challenges in a build and a deploy model is how do you move it across different environments without having to recompile. and change it. So the idea here is that how do you wire when you have a binary that's connecting to a particular backend system or target service in, for example, say your developer environment, and when you move this particular micro gateway binary to the upper environments, how does it now automatically wire to the respective backend service in your staging environment? So in order to do that, you need to have mechanisms of being able to provide these wiring parameters through environment variables and things like that, so that you can do the deployments without having to change or update the binary. So with that, I'd like to give you a small demonstration to show you what a micro gateway experience looks like. So I basically have a definition of my API in the form of a Swagger file. So before that, I'll show you a backend system. So this is basically what you're seeing on your screen. Basically, this particular endpoint on moki.io is can be considered as a target service. So this can be my microservice that I'm accessing right now. So if I make a curl request to this particular endpoint, I should see it responding with the particular message saying hello micro gateway. So imagine I want to create a micro gateway for this particular endpoint. So what I would do is basically to create a definition of my API in the form of in this particular example, I'm using the Open API specification. So in here I have a file called greetings.json. So this basically is an Open API specification. So let me show it to you on the web browser. This is the file over here, as you can see in the URL. So this is an Open API specification of the respective API that I want to host now on my micro gateway. So this has a base path of greetings, a version of 1.0, and this has one resource, or rather two resources, saying say hello, a get and a post resource. So I have this file over here, and let me try to show you the experience, or the typical developer experience of creating a micro gateway now for this definition. So I will have a micro gateway a toolkit or a compiler, and in this particular case, what I first want to do is create a micro gateway project for this particular environment. So I'll mention the project name as greetings, and as input to this compiler, to this build tool, I have to provide the value of the source file basically. So that's why that's what I provide as -o greetings.json. And finally, I have to give the input of what is my target service. So in this particular case, my target service is right here on Moki, and I give this tool the information of my target service and ask it to give me a micro gateway runtime. So if I execute this command, I will see a project directory being created called greetings. So this is basically my micro gateway project, which I can now use to collaborate with my developers and all. So this is like the initial developer experience. So that now that I have my project, the next step is to go ahead and build this project. So if I execute this particular command to build this project, it will now start compiling my microservice, my API definition into a micro gateway runtime, into a binary. So the build is successful. So if I go into this particular target directory, I will see a zip file here. So I can unzip this, where I get a particular directory which has a bin directory. So this is basically my micro gateway runtime now. So I now have a micro gateway that is proxying, that is acting as a proxy for my target service. So I can start this with this particular command. So as you can see now, the Microgateway is up and running. I have a proxy, a secure proxy for my backend service, which is running on port 9095 and 9090. So the next step is to obtain an access token or a security credential to access this microservice. So in my environment, I also have an STS running. So an STS is a component that's capable of issuing access tokens. So I also have a command prepared in here to get an access token. So without going into a lot of detail, I just execute this command to get an access token for me. If I execute this particular command, this curl request on my STS would now give me an access token. So this access token, like I mentioned to you, is a self-contained access token. It's a JWT. So let's inspect it real quickly through this website called jwt.io. So if you look at this token, it's a JWT and it has a lot of information inside it, saying it says the subject, who is the owner of this token, what is the name of the application that is registered on the STS, what are the scopes associated with this, and what is the name of the issuer, and a lot of things like that. So this is a self-contained access token, and the most important part of this is the signature part, which you can't really see here. So this is the information that the microgateway will use to validate the authenticity of my token. So I'll just copy over this access token that I just got into my into this command that I have prepared beforehand. And now let me construct this curl request to send a request to my microgateway. So I'm going to send a request to port 9095 on the base path that I showed you earlier, which is HTTPS localhost 9095 and greetings. So I'm going to send a request to this particular endpoint, and this, yeah, hopefully, as you can see, it now gives me the same request response as my direct backend service on Moki. So if I just play around with my access token, try to change it a little bit, it should now give me, yeah, it should give me an error because the token is invalid. So it's that's the most primary or basic experience of getting a microgateway runtime. So that's what it really means to quickly create a microgateway runtime for your APIs, and how you can quickly create a secure proxy for your microservices. The same actually can be done to create Docker images. So I talked about the experiences or the importance of having to create Docker images and things like that. So the same can be applied. I'll just quickly show you a quick demonstration of that. So again, using the same commands as below above previously, I can use the setup commands to set up a project and give the source file as input, and then provide the endpoint information, and in this particular case, I have a special file called the greetings.toml file, which is like a YAML file, which contains information of the type of Docker image that I want to create. So if I execute this command, it should now create a new project called greeting Docker. So now I can execute the build command on the greeting Docker project. Now this should create the Docker image for me. So like I said, this is the typical experience that one would expect in order to quickly create a Docker image of my microgateway. So I now have a Docker image created. So I'll just show you my Docker processes. Right now I don't have anything. So let me just go ahead and start this Docker image. So I just started my Docker container. If I do a Docker PS now, you will see that I have a Docker image of my microgateway up and running. So if I try to execute the same command as before, now on my Docker container, yeah, it gives me the same response. So this basically typically demonstrates the kind of experience that we are talking about when we are talking about micro gateways. So the reason that these are important, these experiences are important, is again to achieve the agility that we are really looking for. So there's a clear difference between the standard regular monolith gateways and the experience that you get from that versus the new micro gateways that are emerging in order to meet the demands of the microservice development and to match them with the requirements or rather the benefits that we are trying to gain on the fronts of API management. So that basically concludes my presentation and the short demonstration that I had for you today. So thank you all for listening in, and I would see if there are any questions on the panel for me to take. Yeah, so there are a few questions. So I'll start answering one by one. The first question is, how can endpoints be changed on the fly if there is an update on backend service? So this is where service discovery capabilities come in. So microgateways typically should be able to integrate with service discovery tools like etcd console. So in these cases what happens is the microgateways discover the actual urls of the backend services by talking to these service discovery service registries actually, like etcd and console. But of course if you are working in a kubernetes like environment, it's much easier because you can work with Kubernetes services, service names, and the Kubernetes environment will take care of all the routing for you. But that's the fundamental principle. Yes, things can change during the runtime, but the way to deal with that is to work with service registries. Is Microgateway an open source software? Yes. So we at WSO2 have a Microgateway offering, and most API management vendors do now have Microgateway offerings as well. So in our case, yes, everything is free and open source. The other question is, should the API gateway and REST API application? I'm not really getting the entire scope of the question, but what I think what this is asking is whether it supports only REST APIs. So no, that's not the case. A gateway typically should support REST and SOAP at least. And also event-driven APIs are things that are coming up. So like event-driven architectures or event-driven microservice architectures are a thing that's coming up quite frequently now, and therefore it would be ideal if API gateways are capable of handling event-driven architectures as well. So there's another question on saying what is a micro gateway basically. So that's something that I've tried to cover. So the difference between a regular gateway and a micro gateway, as I've tried to explain, is that a regular gateway is kind of a server mode where you deploy things on top of it. But what happens with as you go along your microservice journey is that this regular gateway gets bloated with more and more APIs as you go along, and therefore although you achieve agility on one front, you now make the API gateway a center of excellence, which makes it harder to manage, harder to scale, and things like that. So to deal with that problem, we split up the API gateway into smaller components called micro gateways. And when doing that, it's very important to focus on the experiences, and that's what I try to show in my demo. Because if you have to get agility, we have to be developer focused. So that's because that's where the agility comes from. So what I've tried to show in my demo is how one potential way of achieving that. The most important message is that should be developer focused and agility focused. There's also
Sorry to cut you off, Nuwan. It looks like we have reached the 2 o'clock, so that is all the time we have for the webinar. So I would like to thank you, Nuwan, for a great presentation today. I would also like to thank today's sponsor, WSO2, for providing the audience with a great webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day, and we'll see you next time.
thanks, guys. Bye.